Find the relative extrema of the function f of x is equal to 1/2 x minus sine x in the interval from 0 to 2 pi. How do we do this? Well, we start with critical numbers. Let's find the first derivative, f prime of x being equal to, does that even look like a derivative mark? Let's say it does now. 1/2, no x, minus, and the derivative of sine is cosine x. All right, so to find the critical numbers, we set this equal to 0. So 1/2 minus cosine x. It would never be undefined. Let's go ahead and throw the cosine over. Cosine x is equal to 1/2. And then maybe take a look at a unit circle here. Where's cosine equal to 1/2? Where's the x value equal to 1/2? So it happens in both the first quadrant and the fourth quadrant. That's pi over 3. And then let's see, this 1/3, 2/3, 3/3, 4/3, 5/3, 5 pi over 3. Okay, so there's our critical numbers. We're going to use those to break up this interval here. This is going to look a lot like the test for increasing or decreasing. We just take it a step further. So this is called the first derivative test. And what does the first derivative test for? It tests for relative mins and maxes. So we're going to make ourselves a little sign chart, intervals. Breaking up our domain from 0 to 2 pi. So the first critical number was pi over 3. And then we need to test from pi over 3 to 5 pi over 3. And finally, from 5 pi over 3 to 2 pi. That's not a 3. Now it is to 2 pi. Okay, and then we need to find some sort of test value. So pick something super convenient in each one of these intervals. So using your little unit circle, it should be pretty easy. So right in between 0 and 3 pi, how about pi over 6? Okay, and then from pi over 3 to 5 pi over 3, I would probably pick pi. And then finally from 5 pi over 3 to 2 pi, maybe I pick 11 pi over 6 right there. Let me ask you a question at this point. Where do you plug these test values? You plug them into the first derivative. It is called the first derivative test after all. Okay, all right, and remember that our first derivative here was 1/2 minus cosine x. Okay, if I were to plug in pi over 6 here, so if I plug in pi over 6, that value is definitely bigger than, the x value is definitely bigger than 1/2. So I'm taking 1/2 minus something bigger than 1/2, that's square root of 3 over 2, which is 0.866, blah, 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 blah. It's going to be a negative number. Okay, that indicates that your function must be decreasing on that interval. Okay, all right. Great, let me move this down a little bit. Okay, so now let's plug in a pi. If I plug in a pi here, cosine of pi over here is at xi is -1. So 1/2 minus a negative makes this thing a positive, which means that our function must be increasing there. All right, so I'm going to pause there for just a second. If we decreased and then we increased, what did we just find there? That must be a relative minimum at that particular x value of pi over 3. All right, let's keep going. We've got one more. We've got 11 pi over 6. So 11 pi over 6, like right about over here. That x value is bigger than 1/2. So subtracting off something bigger than 1/2, it's going to leave us with a negative number, which means that we're decreasing again. And then once again, if we increase and then we decrease, yeah, we must have ourselves a relative max. Okay, so under no circumstances would this count as your answer. Instead, this is just the method that you're using in order to draw these little conclusions. So in a justification, you might say something like this. F of x has a relative say the first one was minimum, min the mum at x is equal to pi over 3 because, now don't be tempted to say that our function changes from decreasing to increasing. No, that would be a pre-calculus reason. We must say that our first derivative changes from negative to positive because f prime of x changes from negative to positive at x is equal to pi over 3, okay? Maybe that gets highlighted in, I don't even know, maybe this kind of pinkish color, right? And then you could justify the fact that you have a relative maximum right here at 5 pi over 3 using the same kind of method. So f of x possesses a relative maximum at x is equal to 5 pi over 3 because f prime of x. Now you can think in your head, that this goes from, increasing to decreasing, but if it's increasing, that means the first derivative was positive. Decreasing means that it was negative. It changed from positive to negative. Changes from positive to negative at x is equal to 5 pi over 3. All right, and alternatively, instead of saying that it changes signs, you can say that f prime of x is negative, it's positive to the left and negative to the right of 5 pi over 3. And that would also justify that you had yourself a relative maximum at 5 pi over 3.